Fairy circles are one of nature's greatest enigmas and most visually stunning phenomena. An international research team led by the University of Göttingen has now, for the first time, collected detailed data to show that Alan Turing's model explains the striking vegetation patterns of the Australian fairy circles. In addition, the researchers showed that the grasses that make up these patterns act as eco-engineers to modify their own hostile and arid environment, thus keeping the ecosystem functioning. The results were published in the Journal of Ecology. Researchers from Germany, Australia and Israel undertook an in-depth fieldwork study in the remote outback of Western Australia. They used drone technology, spatial statistics, quadrat-based field mapping, and continuous data recording from a field weather station. With the drone and a multispectral camera, the researchers mapped the vitality status of the Triodia grasses, how strong and how well they grew, in 5 one-hectare plots and classified them into high and low vitality. The systematic and detailed fieldwork enabled, for the first time in such an ecosystem, a comprehensive test of the Turing pattern theory. Physicists have used this model to explain the striking skin patterns in zebrafish or leopards, for instance. The data show that the unique gap pattern of the Australian fairy circles, which occur only in a small area east of the town of Newman, emerges from eco-hydrological biomass water feedbacks from the grasses. In fact, the fairy circles, with their large diameters of 4 meters, clay crusts from weathering and resultant water runoff, are a critical extra source of water for the dryland vegetation. Clumps of grasses increased shading and water infiltration around the nearby roots. The protective plant cover of grasses could reduce soil surface temperatures by about 25 degrees Celsius at the hottest time of the day, which facilitates the germination and growth of new grasses. In summary, the scientists found evidence both at the scale of the landscape and at much smaller scales that the grasses, with their cooperative growth dynamics, redistribute the water resources, modulate the physical environment, and thus function as ecosystem engineers to modify their own envy. Without the self-organization of the grasses, this area would likely become desert, dominated by bare soil, he adds. The emergence of Turing-like patterned vegetation seems to be nature's way of managing an ancient deficit of permanent water shortage. But with his theory he laid the foundation for generations of physicists to explain highly symmetrical patterns like sand ripples in dunes, cloud stripes in the sky or spots on an animal's coat with the reaction diffusion mechanism. Now, ecologists have provided an empirical study to extend this principle from physics to dryland ecosystems with fairy circles. Story source: materials provided by University of Göttingen. Note: content may be edited for style and length. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.